Good morning, everybody. So didn't think we needed a live check-in today. What I want to do in this video is introduce the logic behind where we're going next in the class, which is our second to last thing we're learning, and then review for you in true form how to go through a simulation activity that we're going to do. First off, wanted to say that for all of today's class, you just need a blank sheet of paper. Either find a blank sheet of paper in your notes or staple one to your packet directly. Okay, apologize about this. We're moving into cycle 5, or 6, cycle 5. Hold on. Let's actually take a look together because I think it's really worth seeing. Cycle 6 reactions. So this is the last cycle. Skipped around quite a bit, but that's okay. Love you. All right, so here we go. Logic. We basically spent a lot of time in the course working up to bonding. All right, so if we had something, let's say like water, okay, we worked up to looking at water, okay, being able to draw the Lewis structure for water. And we said that this was the intramolecular bond, right, showing the bent conformation. Then from there, we realized that because of the bent conformation, we have polarity, which gives it partial charge. And because these partial charges do not cancel out, we have intermolecular forces that exist. Okay, an IMF right there. And that keeps something like water from being something that ideally would be a gas. I mean, normally at room temperature, water is a liquid. And those intermolecular forces really are to be credited for that. Conversely, if we have something like carbon dioxide, now while there is a dipole there, and while there is a dipole there, those dipoles cancel out, so we do not report the partial charges, even though there's really actually like a partially negative here and a partially positive here and a partially negative here. We don't report them because they cancel out, and because of that, there's a really weak intermolecular force here, and this substance would be a gas. But up to this point, we've talked about intramolecular bonding, and we've talked about intermolecular forces. But what we haven't done yet is we haven't actually taken this atom that we've made and this atom that we've made and actually smashed them together, right, to create a new compound. We've made them and we've got them close to see how they interact with one another, but we haven't actually sealed the deal and smashed them together. And that's what we're going to be doing in this next unit with chemical reactions. I could show you an example of what I mean by that. Often one of the first things people look at when they study chemistry, but I wanted to build you up to this point. Okay, so like I said before, we were able to draw our Lewis structures. Okay, we have like H2 here, and let's say we react that with O2. We know the Lewis structure here is O2. And in this case, this is the gas. You have tons of nonpolar H2s and tons of nonpolar O2s. But we can actually react those together to form water. Okay. Now this is different than anything we've done before, because in order to do that, you probably see right now, we have to break that bond, and we have to break this bond, and we have to make these new bonds, right? So we're taking something that exists as a gas, because of its intermolecular forces, and something else that exists as a gas because of its intermolecular forces, and we're smashing them together to make new intramolecular bonds. Okay, so that's the first thing conceptually I want you to see. The other thing I want to point out is when you look here, we have 2 hydrogens here, and we got 2 hydrogens here, but we only got 1 oxygen here. So we got to address that, and that's what today's class is going to be all about.